Mother function is what we're going to be talking about today. Cool beans. What does it mean? Okay, well, a mother function is just your basic, well, I guess most people call them parent functions. For linear functions, the mother function looks like this. It's actually called the identity function. Identity. Every linear function kind of stems from this idea. And what does this idea look like? Well, on a graph, if you want to look at the identity function, which is y equals x, or f of x equals x, same thing, right? Well, when x is 7, guess what y is? Y must be 7 as well. Okay, so when x is 1, that means y is 1. Bang. When x is 2, y is 2. Heck, if x is 1, 2, 3, 4, 1, 2, 3, 4, if x is negative 4, guess what y is? Also negative 4. So it looks to be the line that goes through the origin. It almost splits the coordinate plane in half at a diagonal. And I hope it's obvious that any other line you can draw is pretty much this line, either moved up, translated up or down, or left or right, or rotated around. Yeah, so what else can we talk about? Well, let's talk about this. This is looking strangely familiar to us, isn't it? Kind of looks like this. But this idea right here is obviously the identity function. But what is this? This tells you what you're doing with your identity function. So here's your identity function, which is y equals x, or f of x equals x, right here. And if you add b, or subtract b, you're just going to be moving this idea, same exact function, but this is that same function, y equals x plus b. And this one down here might be the same exact looking function, except for slid down. Y equals x minus b. And we know that b, when talking about linear equations, is just the y-intercept. So that makes sense. You're taking your parent function, or your mother function, and you're translating or moving it rigidly, so you're keeping it just as it is, but you're sliding it up or down. And that's what you do with this number b. It tells you how much to move that identity function either up or down. These things just make me so happy up here. Look at them. Look at these little guys. If I wanted to, I can just take one and make it bigger, and then make it smaller. It's so fun. Okay. What happens if you have something like this, where you have, oh my goodness, a slope involved? What happens if that slope is bigger than 0? You know what? I don't even want to talk about this yet. So yeah, what if you had this, where m, or your slope, is bigger than 0? Well, here's the mother function in red, the identity function, y equals x. If you had something that had a positive slope, where this number m was bigger than 0, your only choices are that it heads up and over this line, or your line then becomes a little bit less than this line here. But we know that since it has a positive slope here, that it's going to either be rising quickly with a higher slope from left to right, or rising more slowly with a lesser slope from left to right. Cool. Okay, in the last scenario, what if we had our function, f of x, is equal to mx, where m, this little guy, is less than 0? What would the graph look like? Well, here's your mother function. That's f of x is equal to x. But what happens if we make this slope less than 0? less than 0, so that's negative. Okay, if negative slope, that means it'd be going the exact opposite direction. This function, what would that be? I think it's f of x equals negative x? Is that right? Does that make sense? I think it does. Maybe if you experiment, what happens when x is 3? That means y must be negative 3. When x is 1, 2, 3, y must be 1, 2, 3, negative. Right in there. Cool. Interesting. So that means any variation of this slope that's negative must either be going like this, whoop, or like this, whoop. All of these lines are a result of this function here being acted on by m, where m is negative. Goodbye, Mr. Thing. Whee! Okay, so application. Let's look at f of x equals 2x plus 5. My question would be, how does that differ from the mother function of f of x equals x? This tells us what? That it's moved up 5. That's right, kids. What does this tell us? That it's a little steeper. Oh, great. Yeah, because the steepness depends on the slope. I don't even know if that's a word or spelled right. But yeah, so slope. Here's the slope effect. It makes the line steeper than the original mother function. But the y-intercept tells us that we should go up 5 from the original idea. So it's steep like that, but then up 5 going through this point here. Brilliant! All I want to do with these videos is share some ideas of mathematics with you. So hopefully you get some knowledge dropped in your brain, and then we can play with it together once we get in class. So, yay, math!